Quality of plans.
All right. Hi, everybody. So today I'll be showing you how to implement interrupts. I'm going to cheat a little bit. I have my old code just for efficiency. I will actually translate from Rust to C++. Um, but along the way, I'll try and explain what each thing does. So the other day, I had fixed the bug that prevented it from playing certain ROMs. So we actually it's not in here. So this is tic-tac-toe. This is another test ROM. So one of the ROMs that was not working was what was it? 08. Most of them were not working. 09. This was a simple test ROM that just tested register-to-register operations. And so now, as you can see, it works. 1 second. Takes a little bit. It says passed. I had cleaned up the interface a little bit. I hid the memory viewer and the disassembler behind buttons. So this is disassembler. I decided to cap how many instructions I display. So by default it's 10. So I can say disassemble starting. I know this ROM copies its memory to its instructions to address C00, which is working RAM. And you can see you can disassemble up to as many as you want. And as you can see, I can put breakpoints per line. So we can expand this. We can see it'll break when the program counter is equal to this, this, and this. You can close that window. So it wasn't too much of a change, but it really helped me debug the issue. The issue was I had this increment L instruction. I had accidentally swapped it in the code with the decrement L instruction, and it was really luck that I noticed that increment L was actually decrementing the L register instead. But as you'll see shortly, so where are we now? So that. As you can see, it increments the L instruction right here. So it was more luck that I kind of found that, and then once I fixed that, then the ROM started working properly. So today, I will. So today I'll be implementing interrupts. That's the next thing to test. I have a bunch of test ROMs here, and so I believe the first one, yeah, the second one is an interrupt. I have a flag here that skips the Nintendo logo. So EI's enable interrupts. So in the Game Boy, for interrupts, what we do is before each instruction is handled, before we go through this switch case, we check to see if there's any interrupts to be handled first before we actually execute the instruction. And so I actually, this is my old Rust emulator, which is actually available on GitHub. It has a before we step, we go through this if enabled interrupts, and so we have some data here that in the memory management unit whether to handle the interrupt or not. So there are 5 different interrupts, interrupt addresses, and each interrupt is triggered at a different point. I know V blank is one of the major ones at V blank, which is when the Game Boy finishes drawing a frame. It goes into V blank mode, which means the thing scrolls down and draws each line, and then it has to return back to the top. So that takes some time, and during that time is when the program typically draws graphics. So let's I guess get started here. So let me actually just simply write the code. The code is really not that complicated. It first determines what interrupts to handle, and there's 2 different sets of flags. There's enabled interrupts and requested interrupts. An interrupt has to be enabled and requested in order for the CPU to handle it. So there can be interrupts that are requested but not enabled, and there's a special instruction for that called disable interrupts. So just for the sake of time, I will more or less copy what I had in the Rust version. So, source mem. So these are the weights. Fields, and so each bit in this byte represents an interrupt. I believe the way I have it is since there's only 5 interrupts, only 5 of these 8 bits are used. So let's see. There's a menu. Okay. So one of these is I'll have to kind of try and determine how to organize these fields, because I know order matters in terms of alignment. So requested interrupts. So let's just start with the if statement. We'll do more of that for now. So very simply, interrupts to handle. I spell interrupt wrong. So let me fix the typo. Also, just as a warning, at some point I may have to cut off the stream. I'm expecting somebody, and I'd return later. So let's see. Next step is handle. Then we so there's a concept of halting. I haven't implemented that fully, but since we don't forget, I'll put this in. If there's an interrupt, then we actually get out of the halting state. So I'll put this comment in. So here we have to put the PC onto the stack, because the way it works is that we first service the interrupt. We have to save where we are and then jump to that interrupt address. So either of these 5 addresses right here. And then once we've done servicing the address, then we either continue servicing interrupts, or if they're disabled, then we continue on with the instruction. Actually, I'm seeing here I'm wondering if there's, say, is a disable interrupt. I'm seeing here that we just loop through all of the interrupts and service them if they're enabled and if they're requested. But if an interrupt routine has a disable interrupt instruction in it, I don't know. I would assume we would break out of this loop. We break out of the loop anyway. We only service one thing at a time. Okay, so that must be how it works. So that's not an issue. So, okay. Debug. So what we have is the const routine. So ISR stands for interrupt service routines. So I'm going to actually spell that out. Service routines. Actually, I'll just call them this. This is a little bit better. Addresses. So we have 40. And they just go by 8s. 8, 5, 0, 5, 8, and 6, 0. So there's a priority. Certain interrupts will take priority over others. So even if, say, interrupt at address 50 is requested before an interrupt at 40 is requested, 40 will be handled first. So, rather hex 40. So, actually, So if is bit set interrupts handle. This is what that's doing here. I'm just checking to see if the bit is set at the interrupt to be handled. So the way it works is that for this variable, the lowest bit will represent OX40, and so the next bit is 48, and so up until the 5th bit. So, CPU is equal to interrupt. This is a high. And then we turn off the requested bit. Here bit I. So for this, so as we do this, when we're handling an interrupt, we have to disable interrupts. Otherwise, we would immediately jump to the next interrupt. So we service them, and then there's a return instruction. Typically, I believe there's a ret-i instruction which returns and then enables interrupts to service the next interrupt. So So in this case, I'm curious, where is this is handling interrupt being used? Okay. So we actually add, add 20 cycles if we're handling an interrupt. Okay, that makes sense. So if we're just starting to handle interrupt, it automatically gets 20 cycles added onto it. So, and the problem is I just set it here, so I can't. So that's why I have that that flag there. Is there a bad way of doing this? Yeah, I don't think so, unfortunately. At least this is the simplest solution. I don't like having like flags that are set to true if you're in some if condition. I feel the structure can be better in that case, but I think it's okay. In this case, it's fine. So, after we actually execute the instruction, we do this. If is handling interrupts, then CPU instruction cycles equals plus equals 20. So I think this was a problem at some point. Maybe it wasn't, but I know that we need to make sure the lower bits of the flag register are always 0. So let me see. Let me just pop that in here. As you can see, I was trying to figure out a better way of doing that, but this is okay. Okay. The next stuff is DMA, which we'll probably do later at a later stream. So let's see. Let's test the ROM to see if it works. Let's test the ROM. Enable interrupts failed. Okay. Guess it did not work. Alright. Yeah. So we do have that. Oh, okay. So the next thing that we actually need to put in here is actually putting in the instructions where to actually engage the interrupts. So I know that what I really need to do is look to see where this is set in my code base. So let's use script. So let's see if that's it. Rest new grep requested interrupts. Okay. So let's see. Where is this being used? It's in a bunch of places actually. I mean, alternatively, what I should actually do is actually go through this wiki. And it actually tells you when interrupts are enabled. So let's see. So I know that I have so I don't have the timer interrupt set yet. But because the Game Boy has an internal timer, and after it reaches it counts up every cycle, I believe, um, and then after it overflows, or I think there's another register you can set that when it equals that number, it fires an interrupt. And the joypad is when you hit a button on the Game Boy, uh, it fires an interrupt there. So let's take a look here. So unfortunately, I don't have the controller implemented yet, but I think that's okay for now. So, interesting. So the first thing, let's do this. This is the first thing uh, we'll do is VBlank. VBlank is actually really easy because all I have to do is look at where in the emulator I start VBlank mode, which do some LCD function. Okay. So change to new mode. And let me just confirm over here that that's where I'm going to put it, because I don't want to. I'd rather not have to write it and then realize I wrote it wrong. So what did I do here? So okay, I actually do that. Mode. Request. Oh, okay. I actually set this. Alright, that makes sense. Alright, so to new LCD mode. Step LCD. Oh, nice. Okay, so I already wrote a lot of the structure here. Okay, cool. So actually, right after, after I do step LCD, I do this. New requested interrupts, and it equals temp requested interrupts. I'm sorry, not equals, or equals. So let's see here. Don't think. What is that? implicit. Okay, fine. What is that? I like the warnings, but sometimes it can get a little bit annoying. It's never going to get that high. To int. Oh, okay. Maybe I should just use int, because I really don't care. I don't care about this value. I forgot how I implemented this. Oh, I actually use int. Okay. Okay, so it still doesn't work. It's okay. But let me just see if it actually services some of the interrupts. Let's see. Let's put a breakpoint. Doesn't look like it is. It should have. So this needs to be set. I realize that I did not set this. I need to set this. Okay. That's why. So. Interrupts. So actually, it looks like we interact with this using memory I/O. Okay. So have here. Exactly. This will be the final case. FFF. Address FFF is where you interact with the interrupts. So enabled interrupts equals byte. It's a break. So just simply return. So these are the read byte, write byte functions, and this is write byte, this is read byte. So I believe there should be some. I think Game Boy programs are beholden to write to this address, I think. So let's see here. So let's reset this. Hmm. Swore. Interrupts. That is. So let's take a look here. Because there's two different flags here. There's the master flag, which is uh, this flag. It is enabled. CPU. This flag right here is called the master flag, the IME, interrupt master enable flag. So that's the master flag, and then this register, which is located at address of FFFFF, um, has a granular approach where you can enable or disable certain interrupts. So this is at FFOF. So let's actually implement FFOF. I don't think I've implemented that. No. So one, 40, and here, case, oh, that's FFOF. And this is CPU, another menu, requested interrupts. Let me just double check because there's a to do here, which means that there are addresses here that need to be implemented. I just want to see if I should still leave that to do in there. So let me just check. That's okay, yeah, there's a bunch of stuff here. The joypad stuff. Okay, so I'm gonna leave that to do in here. Okay. And so now let's think. Can you manually request an interrupt? If you can actually. Well, let's see how this does it. Got requested. You just set the byte. Okay, so you can just manually set the byte. Okay, select FFOF. Review is requested interrupts. Byte break. I think technically it really should be this because only the first 5 bits are used, but it really doesn't matter. We ignore the higher bits anyway. So, let's try this again. Oh, you can follow this here. Oh, wait. Oh, it broke. Okay, nice. Okay, so it's in here. Obviously. So what interrupt is this? V blank is bit 0. So this is bit 2. Timer. Maybe it manually requested it. So I don't have the timer implemented yet. That's interesting. Let me just get rid of that breakpoint. Failed. It's fine. Oh, nice stack trace. Cool. It's failed, but it's going into that path. It'd be nice if I had like some sort of code coverage here. I have to look into those tools. Okay. So, actually, you know what I want to do? We want to see. So what is v blank? V blank is bit 0, right? So I want to see if interrupts handle and bit set the 0th bit at interrupts handle. I want to break. I want to see if the v-blank interrupt is firing. This is not immediately. It was fires, so I feel there's something wrong here. Only the timer's the only thing that fires? That's a little bit strange. A little bit strange. Set bit. Oh. Oh, this is a bug. That's weird. Yeah, as you can see, I'm requesting the same interrupt here. That doesn't make any sense. Let me see what IR. Yeah, exactly. Okay. So why was 4? It's so strange. Maybe regardless. Strange. Regardless, this should be this. IR v-blank requested. And I think, well, I guess there's an H-blank. Let me see. Oh, I see. You can configure. There's something called the LCDC register, which I think. Let me take a look into that. Yeah. Display. Yeah, the LCDC. It's like the LCD control. It's a register where you control the LCD. It's 1 byte wide. You can do limited amount of functionality, but there's this coincidence interrupt. And I'm not sure. I don't know what this is. I don't know what the OAM interrupt are and the H-blank interrupt is. Because it's not here. LCD interrupts. So v-blank, that's easy. That's already set. The LCD. Okay. Alright, so this interrupt is shared amongst, I believe, the OEM, a few different events. So what is it? OEM interrupt. So if this is enabled, then we fire the LCDC interrupt. I see. This I don't know. Maybe. No, that's right. This is right. But I believe this is also set. I think these are two different interrupts. Let me just confirm that. And I'm looking for. All right, so let me see. So this looks like. This looks like strictly for the LCDC interrupt. Now I want to also look for where we request the V blank interrupt, because there's the V blank interrupt and the LCDC V blank interrupt, which is very straightforward. Let's see. Let's do interrupts. Ah, this is where we do it. Okay. So, I think it's okay to leave this here. Let me see. Yeah, okay. Yeah, that's fine. Okay, good. Oh, I guess I took out that breakpoint. Okay. Step. Substitute. So let's just put this in. terminal. Oops. P. Like that. It's the timer. I don't understand. Very strange. Let me see. Let me see if that write. Let's see if the ROM is actually writing to here. Bytes. Okay, so we're disabling all interrupts. Let's try again. Okay, so we're enabling the timer. I guess the ROM does this. It sets the timer interrupt, which is okay. Let me see where I am. Yeah, somewhere in the wrong program. This is not the BIOS. So okay, that's okay. So let me see. And there's requested interrupts. Does the timer get manually requested? We have to. If it does, then it makes no sense. Right. I assume this is 0. Yeah. Okay. We enable. Oh, I guess the BIOS does this. Interesting. Bootstrap. So, oh, okay, no, it doesn't. So, okay, so the program writes the timer. Actually, I don't know why I keep guessing here. I can just literally look at the source code for the interrupts. Yeah, it's right here. Okay. Interrupt. So does it only test the timer? I think this ROM is useless, actually. This is just a timer. Okay. I mean, it's not useless, but it's useless for now because I don't have the timer implemented. Okay, okay, that makes sense. But at the same time, I'm a little. I expect the LCD, the V blank interrupt to fire, and it's not doing that. Mm, do I have? Um, I don't have an interrupts data here. Probably should add that. Um, yeah, let me do that. Let me add some. So let me just switch because I think the Bootstrap ROM disables interrupts immediately. Or maybe they're in it disabled by default. I can't remember. Was it? Okay, let me just check to see. By default, I assume that the interrupts are disabled by default, but I am not sure. I assume I would put true here if that's the case. So it's I mean it's possible that the test ROMs just don't enable interrupts. Mm, okay, that's interesting. Looks like the interrupts did affect this somehow. Let's see. Let me. Yeah. So I think I'm going to cut this off in about 15 minutes of other errands to do. Let's see. Debug data. Here we go. So what we want to do is print out at what the interrupt state is here. So enable. Let's just do that. All interrupts. String CPU. Enabled interrupts. Clear. This is interrupts to service. So this will just be, for now, label interrupts and custom interrupts. Yeah, so I'll just have these two ends together. Eventually, I'll probably have like a list of actual addresses to service. So, I apologize if my fan is really loud. Interesting. Is this ever enabled? I'm realizing that this name kind of sucks. I have a CPU, and I know that this is probably going to get confusing at some point. I should probably change these names. Not yet. Actually, what is it? This. Like, is that what I'm trying to determine? Is that a bug in the interrupt routine, or a bug somewhere else? If v blank. So we've enabled interrupts. Okay, so this is the v blank. Do this. So let's have valid LDV. Of course not. Really need to learn my GDB. I'm sure there's a way of quickly getting this, but I just don't know. Okay, so I'm guessing it has something to do with the interrupt service routine because they are enabled here. Interesting. So since we have our disassembler, I mean, we can just disassemble at X40. So the first thing is that we jump to 61. So we disable interrupts. And we do some stuff. We enable interrupts that we do return. Interesting. I'm guessing that this disable interrupts, maybe this routine is used somewhere else. But disabling interrupts explicitly should be necessary. But it's probably a safety measure. It's interesting here because Reta, I believe, enables interrupts automatically. But interesting. Okay, so this I'm going to leave it off here. I might solve this offline or not. And if I do, I'll try and I'll say how I solved it. So I'm gonna leave it off here. Thank you guys for watching. I will post on my Twitter next time I stream. Hopefully sometime this week. Right. Bye.